This is how-to on getting started with GetMapArea for computing the basin areas and stream lengths used by GetNextRad and GetRealTime when you're wanting to record rainfall, compute runoff rainfall using GetRealTime. To do that, close this. Let's go to free downloads. Scroll down to download full GetMapArea and save it. I've already done that. Let's go to where I've saved it, my downloads, and it's right there. Setup GetMapArea. And double click it. Let's run it. Next, and I'm going to put it in program files, GetMapArea. Next, create a desktop icon and install. And if you get the usual error that you already have this file, just hit ignore. And let's launch it. And here we go. Let's continue. And you can see a prompt usually up here that'll help you along. Sometimes on the window, right click for menu, and that would give you this menu. Say if I right clicked, it would just pop up wherever you right click. And I'm just gonna show you, typically you could use a USGS map or a Google map, but I'm going to show you something I just found on provided by the EPA on their watersheds and unit areas, hydrologic unit areas. And for that, let's go to their website at this website page is located at EPA Gov, Waters, Tools, Water KMZ, HTML. If you enter that on your URL address, you can go to this page. And what I wanted to show you here is if you scroll down on this page, we want this raster KMZ. And it provides the stream flows and streamlines in streamlines in the hydrologic units. And let's save it. I already downloaded it. That's why it prompted me to save it. So let's go now. Let's open up Google, and from Google Earth, we can open that KMZ file we just downloaded. Open. There it is. Open. And there that is. And let's get rid of these legends and I'll show you what we really need here. Let's go to View, Sidebar, and in my temporary places I have My Waters. We need to turn on the stream flows, the NHD, and hydrologic units. Everything else should be turned off. Let's turn off the legend and the logo. Let's close this. Turn off that sidebar. Now if we scroll in somewhere, like in Arizona here, let's go down into the Grand Canyon, the tributary. Yeah, you can see the hydrologic units for this area in purple. And if you zoom in even farther, you can see the stream lines, I guess they're called. Let me find out where I was going here. Do that again. Okay, over here on Peach Springs is where I was headed. Find Hell's Canyon. You have to pause and let the raster thing catch up. And here's Hell's Canyon, Peak Springs Wash, and here's the purple is the boundary, and there's the outlet, and here's the longest stream course coming down here. So that's pretty cool. let's make this as big as possible to cover the whole screen. Sometimes this works a little better over here. Let's zoom in a little. Okay, let's put it in the middle. Okay, now let's do an alt print screen, and that'll capture it to the screen. Alternate print screen. Okay, now I've got it on my clipboard. Let's go to our GetMapArea, do a right click, load save map, and let's copy from the paste from the clipboard. Paste from the clipboard right there. And there we go. Okay, now this we can digitize, but first we have to set the scale. You can see our scale down here, 10,231 feet. So let's right click, set scale. The first point on the scale, second point, and it's 10,231 feet. Oops. I'll get it yet. 10,231 feet. So we want feet, and we want our area in square miles for use by GetNexRad and Get Real Time. So there. Okay. Now let's start. Right click on the image and let's start an area. And here's the outlet. Let's start at the outlet there, and we just go around the boundary like this. I won't try to do it very well, just speed things up. Oops. And if you do make an error, you can just undo current line. It'll back it up. Undo current line, back it up. See, and then you can do it a little better, nicer job. But let's get it done here. And right click and end area line. And it's 18.8 square miles around there. And let me just show you how also to do a streamline. Start streamline. And let's go to the longest course. Start it up here somewhere. And just start clicking. I'll go off the line to show you what I'm doing. It's really, you try to follow it. But since it's in blue, it's already there. And then when you get to the outlet end area line, and it shows that the longest length was, well, I don't know, 6 miles. Half of that was below it. Okay, now if we do let's right click on the image and let's add a label so we can remember what it was. And here we go. That area was 18.8, and there's our streamline. So let's just save this image, and it'll save our information there. Load save map image, and let's call it GetMap. One's fine. Save. Okay, now we can recall it if we ever wanted to do an XRAD pixel boundary. We'd be all set to go. Just set a general pixel, and you can redo it. And let's let me just show you that you can continue into runoff hydrograph. If you knew the upper boundary or upper elevation, let's just say it was 5,500 and 3,000 was the lower elevation. Now when you come down here, it'll automatically compute your feet per mileage, slope, and a C that's going to be used in this equation up here to compute the lag time. Pretty nifty, huh? It thinks it's about a 2-hour lag time. I don't know if that's true, but it's a place to start. Normally you'd use a real, well, that's just a place to start. Let's select let's just select the SES dimensionless graph, and you can select none, and it's going to take this 1 hour down here and 1 inch in an hour, and let's give it a some sort of SESCN curve number, and let's compute the hydrograph, and there we go. And that's it.